Good afternoon, everyone, and thank you for joining today's ECA Learning Zone webinar. I'm Omar Khalil, Communications Manager at ECA. Today's webinar is all about improving compliance and safety when testing and maintaining fire detection systems with Detector Testers and ECA Commercial Associate. Today's panel should be up on your screen now, up on webcam there. On your left, we've got ECA's Technical Manager, Darren Cranis, and on your right, we have Paul Gatens, Technical Sales and Support Manager at Detector Testers. I will shortly hand over to Darren for a quick overview of today's topic, as well as a brief introduction to the FSA, ECA's sister organisation, and that's short for the Fire and Security Association. That's a specialist group of ECA. I'll leave it to Darren to tell you a bit more about the FSA shortly. Before I do that, I'd just like to remind you that you can use the question mark button up on your screen at any time during today's presentation to ask our presenters a question, and we'll do our best to answer as many as we can at the end of today's session. This webinar is being recorded, and the full replay will be available on ECA's YouTube channel. That's at youtube.com/ECA Live, which is where we also host replays from the entire ECA webinar series, covering all sorts of industry-specific and technical and commercial topics, electrical and fire and security. With that said, I hope you enjoyed today's session, and over to you, Darren.
Thank you, Omar, and good afternoon to all our ECA members. So my name is Darren Cranis. I'm the Technical Manager here at the ECA. This is an FSA presentation. As people know, the FSA is a specialist arm or specialist group of the ECA. Fire security is a growing specialist area within the ECA and within the industry as a whole. So it's brilliant to know that we've invited Paul here today, and he's going to show us, so those who are involved in fire and security, mostly around the fire, around testing, and obviously safety when it comes with testing those fire alarms. Safety, because obviously normally it's at height. So Paul, if we go on to the next slide. Okay, so the ECA, as you know, has a specialist arm. It's the FSA. It's a very specialist group, and we offer this to all our members, so all those involved in fire and security, and it's about achieving the highest levels of certification, fire security systems. So we're here for new members, here for existing members. We've got a very strong fire and security arm, and as we know, it's a very growing area here in the industry. Next slide, Paul. So, like I say, today Paul's going to talk about the challenges that is involved with traditional fire alarm testing, and also some of the challenges with multi-sensors, heights, all those restrictions. Paul's got some fabulous slides and information on how that can be done safely. So it's about safety while you're testing and still being compliant. So that really summarises what Paul's going to say today. He's got quite an in-depth presentation on how we can help our members stay safe, yet also maintain those fire alarm systems, because from what we've learned, many fire alarm systems may be poorly maintained, and actually at design stage, these systems can go in. So I think I'm now going to hand over. So next slide, please, Paul. So again, so before I hand over to Paul, we've got a couple more slides. If you need to contact the FSA, it's fsa@eca.co.uk. Our technical number is there. You can use the new ECA app, and you can also use our website, and there's extensive guides on our website for members. A lot of members just find it easier just to pick up the phone and talk to us, and we can log your call, talk you through any questions you may have with fire and security. Next question, Paul. So for those who are the ECA or maybe not with the ECA or FSA yet, we do offer free expert technical help, and that is manned by the technical team themselves. So it's our small team, and we man that 5 days a week, 9 to 5. So when you call, you'll get one of us from the technical team. Like I say, it's free technical advice to our members. Not only is it free technical advice, we also unlock free business helplines. So we've got contract and legal, health and safety. We've got our suite of ERAMS products, our suite of BSI products. So if there's a British product, so there'll be a couple, operating standards here today that Paul will probably go into as well. They'll be online if you've got the BSI package through the ECA at a massively reduced price. So I think we've got about 90 BSI standards there through our library. We've got our risk assessment package, ERAMs, which is a brilliant package there, and obviously with access to all our other networking and lobbying events that we do as well. So I think from here on now, I'm going to hand over to Paul and give us an excellent presentation.
Thank you very much, Darren and Omar. Thanks a lot for inviting me along today. So, as we said, improving compliance and safety with technology. That's what I'm going to cover. So a little bit about myself before we get on. I've now been at Detector Testers now for 15 years. It's amazing how quickly that time flies by. Previous to that, I used to work at the Consumers Association on the IT side. And prior to that, I was a Microsoft certified trainer. But more recently, I've been involved with support and training and working on various different working groups that have feed into British standards. So that's a little bit about myself. So what are the common issues we face in maintaining fire detection systems? Well, the installation and ongoing maintenance is unfortunately often seen as a grudge purchase by the client. So this is something that we need to deal with and to see what we can do to overcome. The responsible person premises manager, which is the client, and also the competent person, which is the engineer carrying out the work, unfortunately, they're often unaware of the legal responsibilities and the implications of cutting corners and not complying with standards. There's very little in the way of transparency of the work that's being carried out by the maintenance engineer. You know, the client can't necessarily see what detectors have been tested and what haven't been tested. It's a matter of, relying on a tick sheet. And this all leads to value engineering at the design stage. This is where, the designer has a requirement to put certain specifications and equipment in to meet with standards. And unfortunately, the clients quite often come back and say, what can we do to actually cut costs and cut corners? And this then means that the system that's actually installed isn't necessarily compliant. Another area, which is an interesting one of recent focus within the industry, risks and hazards that impact the performance of the fire detection system are not addressed. And this is being brought to attention by the risk assessors that are actually out there. We are seeing a number of risk assessors that are focusing very hard and looking at risks and hazards, not only to the building and the occupants, but also that will have an impact on the performance of the fire detection system. And equally as well, they're focusing in on safe working practice solutions, which unfortunately are often ignored. So these are two areas which are certainly up and coming. Proof of compliance, documentation not maintained. The fire safety logbook, again, is not really understood the importance of it. And it's a very important piece of documentation. And then generally speaking, it has been a paper-based system up until now, but now we will see we've got a number of other opportunities here. And again, this leads to cheapest contract offer and wins, which again just helps, just further steps down the line, the spiral down to poorer compliance with the standards. A slightly separate area, which is a bit of a concern and a threat to the industry, is unwanted fire signals continue to rise, even though the industry as a whole and the manufacturers in particular have put a lot of effort in to try to reduce that. We'll have a look at that in some detail. And of course, coming back to the proof of compliance corner cutting, which is links into the documentation. One of the things that was mentioned in Dame Judith Hackett's report, which came about after the Grenfell inquiry, she mentions the word competency 152 times. So it's quite well known at government level that the industry as a whole does have an issue here. And there have been a number of steps that have been taken since then to raise the bar, but there's still much more that can be done. And that's what we're going to have a look at. So really, the area we're going to look at is how technology and best practices evolve. So let's just have a look at some of these areas. So one of the areas is in regards to detectors that are in hard to access locations. Unfortunately, many of them are in these hard to access locations. Some of them are impossible to get to, and others are just a little bit difficult. Often go untested. No consideration is given to ongoing safe maintenance, yet there's reference within the HSE. It states quite clearly there that employers are responsible for ensuring the safety of their employees and others. And this can mean in regards to working in confined spaces or working at heights, etc. The CDM, which is the Construction Design and Management Regulations, this echoes what's in the HSE, and it covers ongoing maintenance. A lot of people think the CDM just covers building sites, but it does actually cover ongoing maintenance of a site once it's actually been handed over to the actual client. We've also seen more recently updates within British Standards 5839 Part 1, and this new clause really defines exactly what the issue is. And it says, for remotely situated or hard to access detection equipment, considerations needs to be given to the feasibility of testing and maintenance at the design stage. Now, it specifically mentions the design stage, and this is where designers are starting to get up to speed with this and starting to look to some of the solutions that are available, some of the technology that's come along, and start to specify them within the designs. So really, it's all about avoiding the entry to confined spaces by doing the work from outside, and also, to try to avoid working at any height. And one of the areas, or one of the products that we brought to the market back in 2009 is our Scorpion. Scorpion there's two versions of it, one for fixed point detectors and the other for aspirating systems. And it's the first fixed smoke detector tester that overcomes the need to work at height or in confined space. It carries out a functional smoke test with minimal risk, which is compliant with the standards. And the idea here is that you install that fixed smoke tester, that Scorpion, alongside the point detector here, and then it's wired back to a safe location so that testing can be carried out safely and remotely without having to climb into confined spaces or work at height. And as I mentioned in the introduction, one of the areas that we've seen is risk assessors are now adopting certain best practices. And this is mainly because if we look to the courts, there's been an increasing wider matrix of prosecutions underneath the FSO, the fire safety order, and one of the areas just recently has been fire risk assessors. So fire risk assessors have definitely been, stepping up to the plate. And one of the areas they've been doing is identifying risks and hazards that impact the performance of a fire detection system. And when they do a fire risk assessment, these are the sorts of things they'll be looking out for. They'll be looking for detectors in hard to reach locations or the confined locations. And obviously this helps to promote safe maintenance and working practices, ongoing safe maintenance practices, because it means that you don't have to get into that tight confined space or work at height. So that's just one example of it, and that's our Scorpion fixed smoke tester. As I say, it's been around for quite some time, but it takes time for new technology to get established within the fire industry. The sister product to the Scorpion Point is the Scorpion ASD. Now, when it comes to testing, aspirating fire detection systems, traditional test methods have had their issues. Legacy test methods, they're not safe, they're not repeatable. Hot wire burn, which used to include a PVC coated piece of wire, which electric current was put through, and the PVC would start to burn and create a smoke. And that was one particular method that was established within BT Exchange and used in many locations. But more recently, it's been found that the burning of PVC is carcinogenic, so that one is no longer really carried out. Other forms of testing for aspirated systems involve source of ignition like joss sticks and smoke pellets, etc. Quite frequently, one of the things that was specified or can be specified by the designer who's designing a aspirated system is that they run the aspirated pipe along the ceiling and then they run it down the wall to make a nice convenient low-level test point. Again, because of cost saving and value engineering, often that is actually taken out. When it comes to testing of aspirated systems, there's two methods that PS 5839 Part 1 specify. They talk about the functional test of each sampling hole, because along the length of that aspirating red pipe, you will have a series of holes, and you could do a simple functional test by introducing smoke to each of those holes. Now, the issue with this is that quite often ASD systems are at height and very difficult to get to, so that one's not necessarily always a possibility. A better solution is to perform what is known as a transportation time test, which is also outlined within the standards. And this is where a slug of smoke is presented at the end of the pipe, and because the pipe is drawing the air from the protected area, that smoke travels the length of the pipe. Now, at the commissioning stage, the time it takes to travel the length of the pipe will be recorded, and then any subsequent maintenance visit, they will perform a transportation time test as well, and that test can be compared to the commissioning time. So those are the two methods of testing, and one of the things that we've seen is an increased need to work at height and on confined spaces, using the legacy traditional methods, and the other one is not testing at all, which is obviously not compliant. But again, back in 2009, we released Scorpion ASD, which gives you a safe, repeatable transportation time. It doesn't use any flammable or toxic smoke, so it's completely safe from that point of view. It overcomes the need to work at height or in confined spaces. There isn't now a need, if you don't want to install those low-level test points. You can save some money there and not include those. And it gives a repeatable transportation time test, because if we go back to prior to Scorpion, when they were using sources of ignition like joss sticks and smoke pellets, it was a matter of actually setting the smoke pellet off and then starting the stopwatch. And of course, that's not very repeatable, because when does one person press the stopwatch and stop it may be different to when the maintenance engineer turns off. When you've got Scorpion attached to the ASD pipe, it's cabled back to a convenient place, and when you start the test, the stopwatch is automatically started. So it produces that smoke that's put into the end of the ASD pipe, and you can measure the time it takes to travel the length of the pipe. So that's another example of technology that's been around for a few years, but again, technology, as I say, quite often is slow to be adopted within the fire industry, because we are a little bit of a risk-averse industry. So changing the subject completely now, this one's a little bit more fun, and there's a bit of history here. I want to sort of set the scene as far as reducing false alarms and what the problems we have with reducing false alarms. And if we go back through some of the history here, you can see that back in 1951, we had the first ionisation smoke detector sales started to occur. And it wasn't until 1972 that we saw the move away from ionisation to the optical smoke detector. And the reason for this was that ionisation detectors, although extremely reliable, they do include a small amount of a radioactive isotope, and it was deemed not to be safe to have pieces of radioactive isotope attached to the ceiling. So we had this slow move away from ionisation smoke detectors towards optical detectors, and that's still occurring to this day now. Most of the commercial manufacturers of ionisation detectors now are pretty much come to the end of the production line because of those particular issues. The residential manufacturers stayed with it a little bit longer because it was a tried and tested format. Just to take Apollo, in 1998, Apollo launched their first multi-sensor. So multi-sensors were seen as a way to push back against false alarms by including a smoke and a heat sensor, and looking for smoke and heat at the same time. It could give you a more reliable and resilient detection method. It's less likely to generate false alarms. So that happened in 1998. In 2007, we launched our Testifier product, which was the world's first multi-sensor functional tester. And a lot of people think even today that Testifier is a new product, but it has been with us since 2007. And it's also the year I started with Detector Testers. In 2010, the FIA, with their back office technical team, they came up with some best practices and guidelines on how to test multi-sensors, which basically said, all enabled sensors should be tested in line with the manufacturer's guidelines. So that was establishing best practice then by them issuing those guidelines. In 2011, on the residential side, we started to see an acceleration of technology being introduced into the residential market, which up until that time had been generally low-cost products and low-value products. ECA launched their first multi-sensor into the residential alarm, so that was in 2011. 2015, Building Research Establishment, in conjunction with the FIA, did some research, and they discovered that false alarms are costing £1 billion a year, and the cost was attributed to fire tenders turning up outside commercial buildings because of an automatic fire detection system. So at that time, we had some sort of measurement of the size of the problem. In 2017, British Standards 5839 Part 1 was updated to prescribe the use and test the maintenance of multisensors. So basically, it took 7 years from that FIA best practice guideline to be included in the standards. Again, just an example of how slow things can be sometimes within the fire industry. And that's covered, the whole aspect to do with test and maintenance of multisensors and how to go about that. As I've mentioned, Apollo, it's only fair now really to mention a cheeky, and they launched their first, their ACD-EN, which is the new generation of multisensors in 2018. And the new generation, which are available from a number of manufacturers now, the key difference here between these and those early multisensors is that the new generation give separate sensor indication of activation. So it indicates on the panel or on the detector that the smoke sensor has activated or the heat sensor has actually activated. And there's a really good reason for that, as I'll explain later on. So in 2021, if we look at the latest Home Office stats, we can see that the rate of false alarms is slowing down, but it's still increasing. So this is the issue that we've got to deal with, and I'm still expecting to see further steps to reduce false alarms. So it really comes down to a balance of detector sensitivity. Smart multisensors, do give you that extra resilience, and the way they do it is by introducing longer integrating times. And with the early multisensors, this had a big impact on the test times, the time an engineer spent per detector. And this is one of the reasons why these new generation of multisensors are so much better, because they can allow much quicker activation times. The issue with the multisensors, obviously more skill, knowledge is required and more need for training. And one of the other aspects as well is reduced cleaning of detectors. This is another aspect that's gone on over time. This is an area where the standards talk about service and maintenance, but don't specifically talk about cleaning of detectors. And cleaning of detectors was something that was carried out quite commonly on ionization. And as we've moved more and more towards optical and the more sophisticated multisensors, we're seeing a reduction in cleaning of detectors. Now, the issue here is to do with the optical sensor, because the optical sensors that are now used can be prone to contamination from dirt and dust that builds up inside the chamber. The old-fashioned ionization detectors didn't have that problem. They didn't find that their sensitivity changed over a period of time, and this is what we've learned about optical detectors over the period of time they've been there, is that if you get a light colored dust, it's very reflective, and that increased sensitivity. Whereas you get a dark colored dust inside an optical sensor, that reduces the sensitivity. So this is one of the actual issues here, and there's been again additional technology that's come along where you've got the analog addressable detectors, which have drift compensation and contamination warnings built into them. But one of the things we need to be aware of is there's an awful lot of conventional optical detectors out there, and these could be contributing, or a large contribution to these unwanted false alarms that are actually occurring. Okay. So let's just dive a little bit deeper into multisensors. Multisensors detectors widely regarded as being better at rejecting false alarms than optical smoke detectors of any category. And this is supported again by research by BRE in association with the FIA and the detector manufacturers. And this all goes back to 2018. So they established that multisensors are the way to go. And we've certainly seen a big increase in the number of multisensors that have been installed, since then. The older designs do not give separate sensor activation or confirmation, so they take much longer to test. And the best way of explaining this is to look at the screenshots we've got in the middle here. We've got screenshots from Testifier, and Testifier, as we said earlier, is the multi-sensor. It can test multi-sensors in two different methods. You've got the sequential test sequence. This is where it's got smoke 1, heat 2. So the way this would work is you would test the smoke channel first, you wait for activation, then you test the heat channel and you wait for activation, because the standards are very clear that you have to get confirmation from each sensor. And a sequential test is the way that the older legacy detectors, it's the only compliant way of actually testing them, and Testifier can actually do that. With the new generation of multi-sensors that are coming into the market from Apollo, ECA, and also some of the closed protocol providers, this is where you can do a simultaneous test. So you'd actually put smoke and heat on at the same time, because the panel or the detector is going to tell you that the which sensors have actually activated. And because you're giving that multi-sensor exactly what is required to give it the fastest possible response, you've got much quicker test times. Now, just to give you an example of the amount of time you can actually save, if you're testing a multi-sensor in sequential mode, then you could well find that each sensor takes anywhere between 40 seconds and 2 minutes to test. So, you know, this could actually be 4 minutes per detector. Whereas if you was to test a detector where you can do a combination or simultaneous test, you could well find that the test times are 20 seconds or less. So substantially quicker test times. And again, we should just pay reference to that Home Office stats that show that there was a 1% increase from 2019 to 2020, and there was a 7% increase over the previous 5 years. So it has slowed down dramatically, but it's still increasing. So there's still much more that us as an industry need to do to drive down false alarms. Fire safety logbook. Well, one of the things that we've seen in many parallel industries, and many of you may have come across this being multi-skilled engineers, is that we've seen a reliance on cloud-based and automated solutions. And certainly we're now starting to see this come into the fire industry. There are products now coming to the market which automate the collection of data that proves that the fire detection system is compliant with the standards, and that's the whole point of the fire safety logbook. So we're seeing automatic cloud-based solutions coming there. They also are client-centric, so they're based around the responsible person and the premises manager. The early versions of the fire safety logbook initially were based around the fire alarm engineer, and this wasn't really helping the situation, because we really needed to base it around that premises manager or that responsible person, so that they you know, they know that their system is actually compliant. So that's what we're seeing now, and as I say, a number of different options, and it gives the transparency and that proof of compliance, which is all important. The engineer, the competent person, needs to be familiar with the fire safety logbook, because it could contain important information to assist with the ongoing maintenance, e.g. the number of visits, what there might be a prescription to do with, like testing. Maybe it's an intrinsically safe areas are included on the site, and the risk assessor has actually specified how to go about the testing of those particular detectors in that location. It can also be used, we mustn't forget that the fire safety logbook can also be used in a court of law, not only to defend the responsible person, the premises manager, but also the fire alarm engineer, the competent person. And again, if we look to the Hackett report, Dame Judith Hackett made reference to the golden and fettered information, and this was an acknowledgement that it's time that we moved away from paper-based systems to automated cloud-based systems that just help to prove the compliance. And just to make reference to British Standards 5839 Part 1, the section 48, it says about the fire safety logbook must be kept up to date and readily available for inspection and audit by the fire and rescue service. So that's what we've got, and there are a number of products out there, and anybody that's maintaining fire detection systems should do some research, come and look into some of these solutions, because you're there to provide that information, that extra knowledge, to pass it on to your client and to make them aware of some of these advances in technology. This is an interesting area for me in particular, the residential alarms. We've got an increase in the number of tenants, both private and public. It's just going one way, and that means you've got a landlord that has duty of care. And increasingly, what we're seeing now is that the awareness that you are going to get a higher level of confidence from a functional test using our equipment over and above any form of electronic button test. And we're seeing an acceleration in this particular area at the moment. At the same time, we're seeing an acceleration of new technology coming into residential alarms. They've got new sensors being included in there. So, we've seen CO life safety being included in there, but we're now seeing CO2 and ozone. So some of the devices are measuring air quality. And this is all on the back of what's happened recently with COVID. Interconnectivity and reporting. All these features are adding benefits into the residential market, and it's interesting to note how prices of residential alarms now exceed those of commercial fire detectors, and so the value to make sure that they work correctly is being appreciated more. So best practice definitely indicates that functional tests by a competent person, that's important. It's got to be somebody who's trained, because it's going to give you a higher level of confidence than any electronic self-test. The electronic self-test does have a place. Obviously, that's something that's carried out by the occupier, but there should really be, a functional test by a competent person as well at regular intervals. So coming back to the maintenance engineer and demonstrating competency, and again, I wanted just to dive in on just a couple of key areas here. British Standards 5839 has a very specific clause, 3.12, that has a definition of the competent person that is frequently referred to. And there's one little bit here that I want to pull upon, and it makes reference to relevant and current knowledge. Now, that is a nod of recognition towards CPD, or continuous professional development, which demonstrates the commitment to staff training and maintaining standards. Now, it's interesting to note that within the fire industry, there's certain areas of the fire industry that fully embrace CPD. For example, the fire and rescue service and risk assessors, they're all expected to keep up their training, because once you sign up to CPD, it means that you have a training logbook and you maintain that training logbook over the period of the year. And that training logbook gives a proof of your knowledge is current and relevant. Usually the training logbook is actually brought out when you have your appraisal with your line manager, and you'll go through and see how you've spent your time over the year and the training that you've carried out. One recent area that I've been doing a lot of work with apprenticeship schemes, and it's really encouraging to see that every apprenticeship scheme that I've been through, working with the colleges, all the apprentices have a CPD logbook. So hopefully they're taking them back to their companies, and we'll start to see maintenance engineers and starting to be allocated time by their line managers to make sure their knowledge is kept current and relevant. So current and relevant in what areas? Well, accredited training is available on a number of different sources, and the FSA via Zeus gives you access to multi-day paid-for courses that cover the standards and the law, and they are very important courses to go through, because once you've passed the exams, you've got that certificate, and that's one big tick. But one of the things we shouldn't forget about is the importance of manufacturers' CPD product training, because this is the best source of best practice and new technology. It's not just Detector Testers that offers CPD product training. You know, the likes of Apollo, Ichiki, pretty much all the manufacturers offer CPD training, and it's in the interest of the maintenance engineer to find them and attend those courses. Frequently, they are free of charge, and they, as I say, you will get a CPD attendance certificate, or sometimes there's actually a certificate that's obtained by answering various different questions at the end of the session. The last area that we shouldn't forget about is health and safety training. It's quite frequently overlooked, and just to give you an example that falls in our particular area, our test and maintenance tools are designed to be used at heights up to 9 meters, and this is achieved by using our solo height access poles. And sure enough, we have a CPD self-study course on safe use of solo height access poles. It's one thing to give your maintenance engineer, if you're an owner of a maintenance company, the equipment and the height access poles. It's another to make sure you've provided the training. So you should all be providing them with the appropriate training. And the best way of doing that is to sit through our little 1-hour self-study course on safe use of our solo height access poles. So slowly, we're starting to see CPD being accepted as the best way to demonstrate competency. And really, those areas that I've outlined there are what you should be covering. Okay, thanks for listening. I hope you found that of useful. I'll hand back to Darren, I think.
Thank you so much, Paul. So thank you for your presentation. I know we've been through this a couple of times and I still find that really, really interesting, especially about getting those products for testing being thought out in the design of the build. And I've come across many systems that are in voids. I've got a big telecom background, so Vedsta being one of the leaders for the aspirating systems as well. So I know how important it is to get those tested. But I think those products are really good to help meet compliance on that. But I think it's time that we're going to open up the questions. So I think there's a couple of questions. I'm going to look to my other screen as well on here. So a couple of questions I've got before we open up to the floor with Omar is, are we moving away from aerosol canisters?
That's a good question. That's one that frequently gets asked. Aerosol canisters, as a method of dispersing smoke and carbon monoxide, have been with us since the early 1990s, and they certainly still are one of our leading items that we actually sell. However, there is a growing awareness that we need to look to other alternative solutions. And the reasons for this are a multitude, really. Fire detectors are getting more complex. There are some multi-sensors out there that cannot be tested at all with aerosol canisters. Aerosol canisters are very temperature dependent because they're pressurized containers. And that means that if they're subject to low temperatures, the pressure inside them reduces, which means they don't disperse the product correctly. And it means you don't get the right particle sizes, which can actually mean that you get either slow or no activation. Equally, as the temperature rises, the pressure inside the canister increases, and this then means that you get a faster dispersion, and you can have problems that relate to that. They are pressurized containers, as I've mentioned, and pressurized containers are classified as dangerous goods. And you know, there are a number of providers of aerosol canisters, and everybody is looking for safer, easier methods of distributing products. You know, if you rupture or penetrate an aerosol canister that uses a flammable propellant and there's a source of ignition, you'll get a flashover explosion. It's very rare, but it does actually occur. So there's just a growing amount of awareness, a growing amount of reasons to look to other alternative methods. And this is why since 2007 as a manufacturer, we've been looking at other solutions, and all the new testers that we come about don't use aerosol canisters and use capsule cartridge based solutions. And I think going forward, that's what you're going to see more and more of. I mean, from our point of view as a manufacturer of aerosols, we are continually required to meet the latest legislation, and this continually means, you know, changes to the products, changes in particular to the labeling. You know, as time's gone on, the cautions and warnings that are added to the labels just increased, and it's expected to carry along in those particular ways. But at the moment, they're still here, but there's still very good reason to consider moving to other solutions.
Okay, and I think another one as well is the difference between a functional and sensitivity test.
Yeah, now that's a cracker, that one is. I mean, during the presentation, I was talking about ionization detectors and optical detectors, and I mentioned about with optical detectors, one of the issues we found is that where they can get contaminated with different colors of dirt and contaminants. And if you get those dark colored contaminants, you get a decrease in sensitivity, whereas you get light colored, you get an increase in sensitivity. Well, one of the issues that we've has been more discovered, or is becoming more and more people are becoming aware of, is that when you do a functional test, which is what the most standards around the world, you know, call for, a functional test will always find a decrease in sensitivity. So that means if a detector decreases in sensitivity, it won't activate in a fire. And it doesn't matter if you use an aerosol canister or testifier or any solution, you know, a decrease in sensitivity will be found by a functional test. However, what is now being realized and understood is that when you get an increase in sensitivity, a functional test won't find it. And this is where, if we look to certain regions around the world, for example, in America, Canada and Australia, those are the 3 countries that currently carry out, or their standards call for, a sensitivity test. And this is where you're doing a more exact, precise test of the smoke detectors by measuring the smoke obscuration that's actually putting. So at what level does that detector go into to alarm? Now, this could potentially be the future and the way things are actually going. At the moment, those particular markets, the American, Canadian, Australian market, they use a product that we manufacture that we cannot sell elsewhere. And the reason for that is because the aerosol is not compliant for use in most of the world. It's the F-gas regulations that have come in. So sensitivity testing could well be the future, and an additional way to identify detectors where the sensitivity has increased. And particularly that would be of value towards those conventional detectors that don't have the technology built in to do drift compensation or contamination warnings, which could potentially be a major contributor to false alarms.
Omar, what have you got on your list of questions before we come back to my screen?
There are no further questions from the audience for now, so do feel free to carry on, Darren, and we can revisit the audience questions a bit later.
Okay, so I think important as well, I don't know if we mentioned it, that this webinar port is CPD accredited, isn't it? So everyone on this webinar will receive a CPD certificate. Are there other mentioned there are other CPD courses that either yourselves run and manufacturers as well, aren't there?
That's right. That's true. There's 3 others which are the most popular ones that we run, which are available for everybody to attend. One is a generic test and maintenance of fire detection systems, which covers the law, the standards, and gives an overview of our various different pieces of test equipment. The other thing as well is it tries to give you some indication of trends within the industry as well. So that one proved to be very popular. And we don't just get fire alarm engineers on that one. We get risk assessors turning up. We've had people from the fire brigade on there. Sometimes we get back office staff as well that work at maintenance companies attending that, because it gives them a sort of like a good overview. The other one we have one specifically to do with testing multi-sensors and testifier. That one is a little less popular, but still so. We do run that fairly frequently. And then the final one is the one I referred to during the presentation, which is safe use of the solo height access pole. So they're the 3 main courses that are all CPD accredited. And yes, anybody that's here and stays to the end, that we've got all your contact details. We'll be following up with an email which will have a CPD certificate attached to it.
Okay. So questions from when I used to do some testing bits and pieces is trouble testing heat detectors. I found that was a bit of a concern when we used to test fire alarm systems as a former contractor myself. Can you explain what your experience?
Yeah, heat detectors. Yeah, the heat detectors are an interesting one. That one. I mean, it's quite. Unfortunately, one of the areas here is that previous very old standards didn't have any requirements to test heat detectors at all. And unfortunately, still to this day, there's still a lot of maintenance engineers that are actually out there that have smoke testing tools, but they don't have heat testing tools. So that's one of the issues that we are aware of. When it comes to testing heat detectors, it's important to make sure that you're aware of the product standards and the classifications or the temperature activation points that there are available. There's basically 3 classifications, A, B, and C classifications that come under the product standard EN 54.5, and really what that means is that you need to reach different temperature levels, so 57, 80 degrees, and then above 90 degrees. So in a commercial kitchen, for example, you will always have that high temperature CSCR type detector, and that requires you to get the temperature up to a lot higher. Now, one of our most popular heat testers is the Solo 460, and the reason it's very popular is because it's relatively low cost of actually to purchase, and it's also battery powered. Now, that tester will only test A and B classification detectors. It doesn't have the heat output to reach above 90 degrees. So that's one of the problems that some people experience. They're not familiar with the different heat categories that they're telling them. They've got the battery powered one, which is the most common one. So that's one of the issues they actually have. We're also seeing changes in detector technology where they're moving away from a single thermistor to dual thermistors. Now, when you have dual thermistors, there's always that possibility when you're using a battery-powered heat tester, and I'm talking about the 460 here as well as the testifier, because to maximize the power that they have available, they generate a pencil-thin beam of hot air that's sent across the test cup. Now, with the older heat detectors or heat sensors, they used to have a centrally mounted thermistor, but increasingly now we're seeing, a thermistor on either side of the chamber. And when you're standing underneath it, you can't necessarily see the alignment. Now, if it's one of the lower temperature activation levels, it doesn't tend to cause much of a problem. But as soon as you've got a higher activation temperature, then that can start to cause alignment problems. And some of the engineers have found their way around this by rotating the tester to try to distribute the heat to get that faster activation. The other thing we shouldn't forget about as well is the ambient temperature. Quite often the maintenance engineer is actually on site and testing when the building's unoccupied, the heating's not on, and it's in the middle of the winter. And of course, as soon as that ambient temperature drops down lower, the heat tester again has to work harder. Not generally a problem with the lower temperature detectors, but again can be a problem. And it can mean in some situations you can't actually test them unless you put the heating on or come back when it's actually warmer. So there's some of the issues that are out there when it comes to testing heat detectors.
Okay, thank you. And we had a question in as well, which sort of leads on for that, about can you test CO2 detectors?
Oh, good one. Yeah, that's an interesting one. Again, that's one of the newer questions that we're starting to get through. It's worth starting by pointing out the difference between CO and CO2, because often they are misunderstood. CO is carbon monoxide, CO2 is carbon dioxide. Carbon monoxide is a byproduct of fire, and we do see CO sensors used in fire detectors. It's not as common as everybody expected. Everybody expected CO sensors to be used extensively, and some manufacturers have actually embraced it and others haven't. So it tends to be CO in fire, tends to be a little bit specialized. What we have seen is carbon monoxide growing in CO life safety. And certainly the amount of requests over the years has been more to do with CO life safety. Now, this isn't a market we've particularly gone after, because historically this has been residential market, and our background has always been, targeting the commercial world. But as time's gone on, we have actually had more and more, requests to test residential type alarms, including CO life safety. And there are certain solutions available for certain makes and models, but it's not. It's a little bit of a grey area, and it's not like something that's really easy to describe. So anybody who wants to test carbon monoxide, life safety alarms, the best thing to do is to contact our technical support team, and we can best advise you which solution according to the make and model that you're testing. When it comes to CO2, carbon dioxide, this is a more recent thing, because CO2, carbon dioxide, is generally an indicator of air quality. And this is again where the residential manufacturers lead the way here. And they saw the opportunity on the back of COVID. And certainly we've seen lots of schools, colleges, universities putting air quality monitors in there. And these include CO2 as well as ozone. As it stands at the moment, to my knowledge, we certainly don't manufacture any CO2 test equipment. And I don't think anybody else does, but I'm not 100% sure about that.
Okay, and I'm actually on the back end of that as well. You talk about now you're seeing a lot more technology in the homes, so multi-sensors, etc. We're all used to pressing the test button in our own homes. What's the difference between that sort of test and the test button and the functional test, for example?
The electronic test button and the functional test, that's again, it's a good thing to clarify that. And what we've had historically for a number of years, obviously in part 1 of 5839 here in the UK, that covers the commercial detectors, and it's been very specific that says you have to carry out a functional test, and it has a definition of the functional test, and it says firelight phenomena can travel unhindered from the protected area into the chamber and cause an activation. And that's what is known as a functional test, and that's what part 1 calls for. It also then goes on further to say any electronic button test isn't compliant with the standard. Now, when we look at the residential side of things, that comes from a background of electronic button test as being the preferred way to go. But with the last update, the 2019, it lifted up the whole service section from part 1 and dropped it into part 6, but then it had an additional little caveat to the bottom, and it said subject to the manufacturer's recommendation. So it was leaving it down to the manufacturer whether they recommended a functional test, over and above a button test. But really what it comes down to, the reason you get a high level of confidence when you do a functional test is you're proving that smoke, heat, CO, or any combination of that can travel from the protected area into the chamber and cause an activation. And one of the best things to explain where you get that confidence from is just to explain a couple of scenarios I've seen. And I've seen this situation on a couple of times with both residential and also with commercial detectors. And this is where there's been a very strong negative air pressure, i.e. the detector or alarm is mounted onto the ceiling, and there's a void behind it, where they've got a strong airflow. And I've actually seen the situation where the smoke is actually sucked around the side of the base up into the void, and a functional test actually won't cause an activation. Yet when you do the electronic button test, it says, I'm working, I'm fine. The device is actually okay, but it's the installation that's actually at fault there. And that's where you'll get that higher level of confidence from a functional test over and above an electronic button test. As I mentioned during the presentation, we'll be the first to point out the electronic button test does have a place, but that's a simple, easy test that the tenant or occupier can actually carry out. But when it comes to a functional test, we're very clear on this to echo what's actually in the standards, and that a functional test should be carried out by somebody who's competent, i.e. a fire alarm engineer. So I hope that helps.
Omar, have we got any more questions come in?
No further questions in the audience section. Unless there are any final comments from you, Darren, I suggest now would be a good time to wrap up this afternoon.
Yeah, I think the final one from me is also, we just talked about the standards, which I think is a great final question to end on, is Paul, what changes do you think you expect in the next edition of 5839? You've talked a little in the last couple of questions there, so what change do you see?
There's a number of possibilities being discussed. The whole false alarm issue is one major problem, and the industry as a whole is looking what else can actually be done. And certainly there is awareness of this issue to do with dirt and contaminants getting inside the optical chamber being a particular problem. And if we look to other areas around Europe, for example, mainland Europe, Germany, Spain, France, etc., they've gone as far as putting age statements within their standards to try to address this issue of dirt and contaminants getting in there. So, for example, the German standards actually call for devices to be replaced at 8 years if they are conventional and have some sort of drift compensation and contamination warning, whereas it's 5 years for conventional detectors. Now, that's all well and good, but if you were to follow that standard, or if we were to follow the same line here, it would mean an awful lot of devices would be thrown in the bin well within their life expectancy. Because don't forget, what we've got here in the UK is that British standards make reference to the manufacturer's life statements. And the manufacturer's life statements, which are given, are usually 10 years. There are some exceptions to that. And those life statements are based on a mean time between failure for the components used within those detectors. Now, 10 years is what, for example, Apollo and Achiki actually give on those. But of course, if it's got a CO cell in it, CO cells have a much shorter lifespan. So you could actually see 5 years or 8 years, on a device with a CO sensor in there. But that's the life expectancy. And those manufacturers' life statements do not take into consideration dirt and contamination. And really, the standards at the moment really are reliant on, if it's an addressable system, you've got those analog values to refer to. But if you haven't, then really, it's the only fallback is the cleaning. If you do regular cleaning, you will, if regular cleaning is carried out, you will extend the life of that device, but in a dirty and contaminated environment. But if you don't, then the device will have a much shorter life. So there's some talk about including life statements within the standards. I hope it doesn't go that way, because I don't think that's the right approach. But it certainly, there's been discussed, and that is one thing that may be a possibility. I'm hoping that we might see some simplification on the whole false alarm monitoring side of things. There's a whole series of calculations of a rolling 12-month period to work out whether you need an in-depth investigation or a preliminary investigation. Now, frequently that's not carried out because it's just seen to be too complex. Now, again, with the online fire safety logbooks, a lot of these products now actually automate that whole process and are making it simpler. So if we see a bigger take up of those, that will actually help to address that area. But it may well be that we see a simplification of the method of calculation that's actually carried out. So that's another area there. Obviously, another area which is, we can't avoid. We're constantly reminded of our impact on the environment, and we've got lots of engineers driving around the country, up and down, visiting sites. And the standards say that the detectors should be tested at least once, and you should be at least 2 visits a year to each particular commercial site. and it can be more frequent than that with bigger sites, or if the risk assessment calls for it. Well, this all has a cost and an impact on the environment. So there has been some discussion around, how can we remotely test these devices? So maybe looking to move towards, one test a year or one visit, per year, and having some sort of automatic testing. Now, this is still early days. Obviously, from our point of view, we're very interested in this, and this is an area which potentially could have an impact on our product and our sales. But at the end of the day, the environmental legislation that's following along could well have an impact on us in our particular industry. We're kind of already, halfway there, because as I've covered, we've got our Scorpion, products actually out there, and it could be future releases of Scorpion could well, help to address or move things in that particular direction. I wouldn't expect that change to actually come about in the next release, but there may be changes that move closer towards that for the future. So there's just a few that are possible. These are my opinion, my take on the situation, and there are a number of different other areas that are being spoken about as well.
Okay, well, thank you very much. I think, Omar, are there any questions from our audience?
No further questions from the audience. I think that'll be a good time to wrap up there for the afternoon. Massive thank you, Paul, for your presentation. A really in-depth look at some of the challenges of compliant testing there, and some really good examples of best practice. And as Darren mentioned, this session is CPD accredited, so those of you watching live right now will have your certificates making their way to you by email very soon. And if you happen to be watching this as a replay on our YouTube channel, or if you're catching us on social media, and you have any questions for our panel that we haven't covered today, please email them to publicaffairs@eca.co.uk, and we'll do our very best to get those answered for you. Just before we sign off, Paul, I can see you've got your own contact details for Detector Testers up there on your screen if people want to get in touch with you, find out more. And with all that said, big thank you to our panel and to our audience today, and have a great afternoon. Thanks, guys.
Thank you very much. Cheers. Thank you.
Take care. Thank you.